Good morning, students. In our previous classes, we have already discussed what is dimension, what is dimensional formula, then applications of your dimensional formula, how to find the dimensions of the constants that we have used in several physical relations, and we have discussed regarding the significant figure also and what is the error. So today, as we have completed our unit and measurement chapter, today we will discuss some of the numerical problems from that unit and measurement chapter. So before that, we should recall one point, that is what is meant by principle of homogeneity. And we know, according to principle of homogeneity, a physical relation is dimensionally correct if the dimensions of the used fundamental quantities on each and every term on either side of that physical relation remains same. According to, based upon that principle, we will today discuss some of the problems. Okay, so one such problem we will do today from the, we will solve here some of the problems and you will go through your material for the rest problems. Anywhere you are getting doubt, you can call us. Okay, so student, the first question given here it is, write the dimensions of A and B in the relation P equals to B minus x square by 80, and here the P is your power, x is the distance and T is the time. So this is the given physical relation, already it is mentioned, it is correct one. And we have to find the dimensions of what? Dimensions of your A and B. These are the constants used in this relation. So this relation now we will use here the principle of homogeneity. According to the principle of homogeneity, the dimensional formula of this equal to the dimensional formula of this. And also you can say, we know if x is subtracted from B, that means same or like quantities can be only subtracted. If x is subtracted from B, that means it is having same dimensions to that of B. Clear? So first of all we will try to write the dimensions of B. Here dimensions of B equals to, dimensional formula of B equals to, dimensional formula of B equals to, otherwise you can write x square. Dimensional formula of x square. Dimensional formula x square. And x means what? X is given distance, its square means what? It can be written as m0 L2 T0. So this is the dimensional formula of your x square. So as you know, x square is subtracted from this, so dimensional formula of B is also equals to m0 L2 T0. Clear? Now we find the dimensional formula of 80. So you see, suppose this is distance, this is distance, distance minus distance will give you what? Distance. So instead of writing two times, दुई थर लेखिबा बदलरे आमे जे कोनोसी b पई हो किबा x स्क्वायर पई हो, we can take the dimensional formula once. We should not use repeated time. That means m0 L2 t0 minus m0 L2 t0 will give you m0 L2 t0 only. Okay, that means we will write again, we can say P equals to, we can write the same by x square by 80, or you can write also P equals to B by 80, no problem. Okay, so here from that we have to find the dimensional formula for A. So A will be equal to x square by P into T. Here, so therefore dimensional formula of A equals to P. P means here P given power. Power means work by time. So work you know m1 L2 T minus 2 by time T to power 1. So when it goes up, it becomes how much? m1 L2 T minus 3. So this is your power. So you can write here A equal to x square means L2 by, this is your m1 L2 T minus 3 into T to power 1. So how much it becomes? So this is your L2 divided by T to power minus 3 into T to power 1. So this is T to power 1. So how much it is? T to power minus 2. So when it goes up, this is your M1 L2 T to power minus 2. Now when it goes up, how much it will be? M minus 1. Here L2 L2 cancels. L0 t to power 2. Okay. It is minus 2 when it goes up, it is t to power so. This is your dimensional formula of your A. M minus 1, you can say L0 t to power 2. Clear? This is the first question now. We will go to the next question now. So the second question is given here. The velocity of a particle depends upon time t according to the equation v equals to root over of AP plus BT plus C by D plus T. So identify which physical quantities A, B, C and D are. So here you students, though this is a given physical relation, according to the principle of homogeneity, the dimensions for the used fundamental quantities in V is the same to that of the dimensions of the used fundamental quantities in root over of AB. Dimensions of V should be equal to BT. Dimensions of V will be equal to C by D plus T according to the principle of homogeneity. So we have to find out these dimensions and dimensional formulas of these constants A, B, C and D for this given physical relation. Okay. So for that let us use the principle of homogeneity. So I will start to find from this side suppose. You see here B plus T is given. As I have told you, the like quantities can be added. The dimensions of T should be equal to the dimensions of D. Therefore, first I can write dimensional formula of D equals to dimensional formula of T. Clear? That is, you can say D should be equals to T means time. T is here time. So T stands for what? M0, L0, T1. So what T stands for? Now we got the dimensional formula is M0, L0, T1. And this is the dimensional formula of what? Time. So the given physical quantity for D is how much? Time. So D because stands for here D having the same dimensions to that of time. So the given physical quantity is time here. Next we will go for finding C. As it is D plus T, time plus time gives you time. So we can write again dimensional formula of V equals to, we can write that is C by T, because D plus T equals to otherwise T. No need to write 2 times the dimensional formula. Therefore, what will be the formula we will get here for C? C equals to V into T. And V stands for here what? Velocity. Therefore, dimensional formula of C equals to, velocity means it is L1 T minus 1 into T to power 1. So T cancels, remain is L1. And L1 means what? It indicates otherwise the physical quantity distance. So the given physical quantity now it is distance. Here, this is for C. Now we come to the case of BT. Dimensional formula of V equal to BT. Dimensional formula of V equal to dimensional formula of your BT, or dimensional formula B will be equal to dimensional formula B equals to V by T. V means velocity. Velocity means L1 T minus 1 by T to power 1. So when it goes up, it becomes how much? L1 T minus 2. And we know M0 L1 T minus 2 it is your acceleration. This is your acceleration. So the given physical quantity is your acceleration. Here, next we will go for to find the dimensional formula for your A. So for that, we will use the equation you see. Dimensional formula of V equals to, dimensional formula of V equals to, this is your root over of AB. So you can make it AB to the power half, it is okay. Or also you can make square on both sides, it is also okay. Both are right. Therefore, we can write if you will make square on both sides, v square equal to ab, or you can say a equal to how much, v square by b. Therefore dimensional formula of a equals to v square, v means L1 t minus 1 its square by b, and here also b means what, b we have already found it, dimensional formula b is equals to L1 t minus 2. This is L1 t minus 2. So if you will cancel here, you see here it is how much, I can erase this portion now. This I have written as what, v square by b. So if you will cancel this portion, how much it is, this is your L2 t minus 2 by this is your L1 t minus 2. So t minus 2 t minus cancel, when it goes up it becomes L1, and L1 stands for what, distance. So this is indicating you, otherwise giving you the distance. So this is the second problem I have done for you, where we got the values a, b, c and d. So the next question is, students, here you have to convert the value of a physical quantity that is given in one system of unit, and you have to convert into another system of unit. Conversion of physical quantity from one system to another. But we had also discussed that if the value of physical quantity in MKS and CGS, how we are taking. In CGS system, we know mass we are expressing by 1 gram, length by 1 centimeter, time by 1 second. But here question you see, the density of a material in CGS system is given this much, and you have to find in a system of units in which unit of length is given 5 cm and unit of mass is given 20 gram, then what is density of the material? So here you see, we have unknown, we don't know about that unit in which the mass means the density is 8 gram per cm given, and also you know here given mass is 20 gram. We don't know in which unit the mass it is 20 gram, and in which unit the length is 5 cm. So further we will use or we will consider it is to be a new system of unit. Okay. So here the density, first of all I will write here on the left hand side, that is CGS. Okay, because the condition is given in CGS system, and on the other side I can take it new system of unit. New system of unit. Okay, and here though the density is given, so the physical quantity is your density. And density means you know mass by volume. So the dimensional formula is m1 L0, mass by volume L cube, L minus 3 T0. M1 L minus 3 T0. Therefore from this we can say A is how much, 1, B equals to minus 3 and C equals to how much, 0. And in CGS system we know mass equal to 1 gram, length equals to 1 centimeter, time equals to 1 second. And remind it, here given is 8 gram per cm cube. So this is given your N1. That is given your N1. N1 equals to given 8 gram. That means 8 given. N1 is given 8. And on the other side, we have to take mass. Mass is given, you see. As I have written, this is new system of unit. That means in that system the mass is given how much? 20 gram. It is given 20 gram. And length is given how much? Length is given your 5 cm. Length is given 5 cm. Here. So here also we can do, take time. And d2 equals to given 1 second, and we have to find the value of n2 here. Okay, so you just first take this one. So I am now just erasing this portion. So students, as we know, n1 u1 equals to n2 u2. We know already, previous classes I have already told you, n1 u1 equals to n2 u2, and here question is to find n2. That means you can say N2 equals to, otherwise you can write N1 U1 by U2. And U1 means you know it is M1 to the power A, L1 to the power B, T1 to the power C. And U2 means you know M to the power A, L to the power B and T to the power C. Therefore N2 equals to N1. N1 is given how much? 8 into U1. So this is M1 to the power A, L1 to the power B, T1 to the power C divided by U2, M to the power A, L to the power B and T to the power C. And we know though the powers are same for M, L, T, that can be otherwise written as M1 by M to the power whole to the power A, L1 by L to the power whole to the power B and T1 divided by T2 whole to the power C. Okay, so now here I can erase for you. So you see here it is 8, which implies N2 equals to 8. M1 means how much given? 1 gram by M2, how much given? 20 gram. Its power is A means it is given 1. L1 means how much it is? 1 cm divided by, this is 5 cm. Its power is 2. 2 means how much? Minus 3. And here you can say time. Time it is given here 1 second by 1 second. And its power is your how much? 0. Okay. That means one way you can say for the measurement of the given physical quantity, though its power 0 means we can say also it may not be used in the given physical relation. So here you can take, now you can solve this one. How much it is? You see gram cancels. Here it is cm cancels. Here totally it is 1. So remaining is what? N2 equals to, this is your 8 into 1 by 20 into, this is your 5 to power minus 3 when it goes up, 5 to power 3. So it becomes how much? 5 5 is 25, 5 is 125, 125 into 8. So this is your almost 1000 by, this is your 20. So how much it is? So answer you got it to be 50. So finally you got N2, it is how much? 50. Therefore you can say what it was given in one of the system, it was given 8 gram per cm cube. So what you got now in the new system unit, its value is how much? N2 is how much? 50. But here you cannot write it is in the CJ system. We will write 50 in new system of unit. New system of unit. Okay. So students, next is given Reynolds number used for determining the streamline flow depends upon the velocity of flow V, density of liquid rho and coefficient of viscosity eta. So it is actually Reynolds number, it is your dimensionless constant and it depends upon three things. As we have already in previous class, we know how to establish the relation among various physical quantities. And also we know some limitations. If more than 3 physical quantities are there, then it is unable to express, or you cannot establish the relation because its power, we cannot use the fourth quantity. So here you can say, though Reynolds number depends upon, I can say R depends upon first velocity of flow. Let I will take it to be V to power A. Suppose it is equation 1. And it depends upon the density of the liquid. Let it depends upon rho to the power B. And it also depends upon coefficient of viscosity eta. It is eta to the power C, equation 3. So there are 3 equations we got. And finally it is given again, you see, if R varies directly on the diameter D. Diameter D means also you can say it is directly proportional to D to power. D means it is simply we take 1 because as per the limitation of your dimensional analysis, more than these 3 physical quantities we cannot use it. So for that I am taking, let its power it is 1 because it is given, it is also directly proportional to the diameter. Let it is equation 4. Combining all these 4 equations, what we will get here? Combining all these 4 equations, 4 equations we get. You see, we can write here R is proportional to V to power A, rho to power B, eta to power C and D to power 1. Now we will take dimensional formula on both sides, or you can say if you will eliminate this proportional sign, what you get? K V to power A, rho to power B, eta to power C and D to power 1. Let it is equation, you can say 5. Now taking dimensions of the used fundamental quantities on both sides of the equation, what happens? Just take the dimensions. Taking dimensions on both sides of the equation, we get, you see, for the Reynolds number, as it is a dimensionless constant, we can take its dimension as what? M0, L0 and T0. Here, so you can write here R equals to, for R I am taking M0, L0, T0 as it is I have just taken, K, next V to power A. This is given velocity. Velocity means we know it is L1 T minus 1. Its power it is A. Rho, density. Density means mass by volume. It is M1 L minus 3. M1 L minus 3 e to power 0. Its power is how much? B. And eta, it is known as coefficient of viscosity. And its formula is, you know, M1 L minus 1 T minus 1. Its power is C. And finally, it also depends directly on the diameter. So diameter means we are just taking its length. It is a type of length only. So we can represent L1 for it. Clear? So now it becomes M0 L0 T to power 0 equals to K as it is. You see, here M to the power B, here M to the power C. So M to the power B plus C. We can write here M to the power B plus C. L to power A, L to power minus 3B, L to power minus C, L to power 1. So how much it is? You can write it to be L to power A, this is your B minus 3B, this is your minus C, this is your plus 1 you can say. And T to power minus A, here it is 0, here it is plus C. So we can write it to your place T to power minus A minus C. Here. Now comparing both sides of the equation, we get how much it is? You see, M to power 0 equal to M to power B plus C. So we can write it to be B plus C equals to 0. Similarly, L to power 0 equal to A minus 3B minus C plus 1. So we can write A minus 3B minus C plus 1, it is equals to 0. And finally, another one is there, minus A minus C, it is equals to 0. Okay, so here you can take now, this is minus A minus C equal to this much. From the second you can say A minus 3B minus C, it is equals to minus 1. Here. So from this equation you know, you can say here minus A minus C equal to 0. So minus A equal to how much? C. So C becomes equals to minus A. Similarly here you see B plus C equal to 0. So C becomes equal to how much? Minus B. So now you convert all these into one form, either A, either B or either C. So suppose I will write here, if I will write A, then A will be how much? A will be equal to minus C. So minus C. Minus 3 into B. B means also minus C. Okay. Minus C equals to minus 1. So it is how much now? Minus C. Minus into minus, how much it is? Plus 3C. Minus C equals to minus 1. So minus C, minus C, minus C, minus 2C plus 3C. That means C. C equal to, we got it to be minus 1. Now you put here, if C equal to minus 1, then A is how much here? A equal to minus C. So A will be equal to how much? Minus of minus 1. That means it is 1. Okay. And the same thing you put here. C equals to minus 1. So minus 1 equal to minus B. So minus minus cancelled. So we got also B equal to 1. So now we got all the values. A equal to 1, B equals to 1 and C equals to minus 1. Putting these values in equation 4. How much you will get it? Just I am erasing the upper portion. Putting the value of A, B, C. Putting these values of A, B and C in equation 4. In equation 4 we get you see in equation 4 it is how much? R is equals to K V to power A. V to power A means A we have got it is to be 1. V to power 1. Then it is given rho to power B. Rho to power B means it is given 1. And finally it is known eta to the power C. Eta to the power C means it is minus 1. And D we know it is simply 1 because it varies directly to the diameter. It is given to you. And here it is a minus is there. If you try to find value of K is also given 1. So if you will put the value of K equals to 1, then remain will be how much? V to power 1, rho to power 1, D to power 1 by eta. And also you can write simply as V rho D by eta. So this is the given relation for your Reynolds number, which is equals to V rho D by eta.
Now let's start another one question regarding error. Now come to the solution part. And given that there is a physical relation, and here P which is equal to L cube B square T under root of D. So we have to find here percentage error in P. But given that in a measurement the percentage error L, B, T and D which is given by 1%, 2%, 4% and 8% respectively. Clear? So we have to find percentage error in P. So how can we find percentage error in P? But here this is the power format. So I am writing here the absolute error of P, that is delta P by P into 100 means percentage error in P. And this can be write here power format 3. So first I am writing 3 into delta L by L plus here B square means 2 into delta B by B plus here T power 1. So delta T by T plus here under root of D means that is D root 2 which is equal to D to the power half. So you can write here 1 by 2 delta D by D. Clear? Okay. So how can we find percentage error? Because here absolute error, that is delta relative error delta P by P. If you into 100, then you will get the percentage error in P. So we can write here delta P by P into 100 equal to 3 into delta L by L into 100 plus 2 into delta B by B into 100 plus delta T by T into 100 plus 1 by 2 delta D by D into 100. Clear? So this is percentage error. So given that the percentage error of L, B and T and D is given 1%, 2%, 4% and 8%, that means here given percentage error in L. So percentage error in L, that means delta L by L into 100 which is given here, that is 1%. So you can write here 1%. Similarly, percentage error B, delta B by B into 100 which is equal to here given that is 2%. Clear? So in this way, if we use all the value, then we can write here 3 into delta L by L into 100 means percentage error in length or L which is 1%. So you can write here 1% plus 2 into delta b by b into 100 and given that percentage error which is 2% into 2% plus delta t by t into 100 and percentage error in t which is given 4%, so 4% plus half of delta t by d into 100 means percentage error in d and it is given 8% into 8%. Now solve this relation, so here we get that is 3% plus 2 to the 4% plus 4% and plus 2 to the 4%. Clear? So 4%, 4%, that is 12 plus 3 which is equal to 15%. So percentage error in P which is equal to 15%. This answer. Now let's start another one question. Calculate the focal length of a spherical mirror from the following observation, and it is given that the object distance u 50 plus minus 0.1 centimeter and image distance v equal to 20 plus minus 0.2 centimeter image distance. Clear? So it is given that object distance and image distance. You already know the focal length. How to calculate in spherical mirror case? It is 1 by f equal to 1 by u plus 1 by v. What is u and v? U is object distance and v is image distance, and f, what is f means focal length. But we have to calculate here error in focal length or maximum error in focal length. So how can we find this error? First I am writing here u equal to, that is 50 plus minus 0.5 centimeter. Clear? And here u equal to, here this term is known as true value, that is 50 centimeter, and error means 0.5 centimeter. This is error limit, so you can write here delta u which is equal to 0.5 centimeter. Similarly v given that is v equal to 20 plus minus 0.2 centimeter, where v or true value which is equal to 20, because we already know the relation, that is a equal to a plus minus delta a, means this is true value and this is maximum error, maximum possible error in a. So that here v equal to 20 centimeter you can write here, and delta v, error in measurement of that is image distance v, that is delta v which is equal to 0.2 centimeter. Clear? Okay. But we have to find maximum possible error in a. So if you take 1 by f which is equal to, take LCM u v, then this term will be u plus v, or f equal to u v divided by u plus v. But we have to calculate maximum possible error in f. So I am writing here, that is delta f, because this is division method and we already know division method, that is suppose z equal to a divided by b, if the result z equal to a divided b, if error in a and error in b, then the error content, that is z, and final result consists with error. So you can write here, that is delta z by z equal to delta a by a plus delta b by b. By use this relation here, so here f equal to a by b you can say. So f means delta f by f equal to, suppose this quantity is a, so I am writing directly here delta means here multiplication case. For multiplication and division case, the maximum possible error can be write this format. So I am writing this format directly here, that is delta u by u plus and then v delta v by v plus, and here the remaining part u plus v means delta u plus v divided by u plus v. Clear? So if you rearrange, if you write another format here, so delta f by f equal to delta u by u plus delta v by v plus delta u plus delta v divided by u plus v. Clear? So first we have to find what is the value of f here? So first we have to find f because we have to find maximum possible error in f. So f equal to f plus minus delta f. And this is error and this is true value. So first find true value here. So f given that is f equal to uv by u plus v, uv divided by u plus v, and u is here 50 centimeter, 50 into v is here 20 centimeter, 20 divided by u plus v, 50 plus 20, it is 70. Clear? So if we cancel this term, then f equal to 5 to the 100, sorry 50 to the 100 divided by 7, which is equal to 14.3. Clear? This term is 14.3 centimeter. This is focal length or true value in case of focal calculation of focal length. Now we have to find the value of delta f. What is delta f? Delta f is here absolute error or error limit or maximum possible error in f, and we have a relation here delta f divided by f equal to this much. So we can write here delta f equal to delta u divided by u plus delta v divided by v plus delta u plus delta v divided by u plus v into here f, now multiply here is f. So by using the value of uv and f, delta u and delta v in this equation, we can find the maximum possible error in f. Clear? So now use the value here. Now we have to calculate delta f. So delta f equal to delta u by u, and here delta u, that is 0.5 divided by u, and object distance given 50 centimeter, plus delta v by v, and delta v is here 0.2 divided by 20 plus delta u plus delta v, and given that delta u 0.5 plus 0.2, 0.5 plus 0.2 divided by 70, u plus v, which is 70 into f, and we already find the value of f is here, that is 14.3 centimeter. Clear? Okay. Now solve this equation. So we will get here 0. If we solve this relation, that is 0.01. And again 0.2 divided by 20, which is equal to 0.01 plus, and here that is 0.7 divided by 70, also we get here that is 0.01 into 14.3 centimeter. Clear? Now solve this relation here. So 0.01 says same quantity, so we can write here 0.03 into here 14.3 centimeter. Clear? If you multiply this relation, then you will get the approximate value, that is 0.43 centimeter. This is maximum error, maximum possible error in calculation of focal length of the spherical mirror. Clear? So final result can be right here. The f equal to true value, and given true value is here 14.3, that is 14.3 plus minus, and delta f, delta means possible error here 0.43, this is centimeter. Clear? This is final answer for calculation of focal length of a spherical mirror. Clear? Now let us start another one question. The time period of simple pendulum, which is given that t equal to 2 pi under root L by G, and given here t equal to 2 pi L by G. This is the equation for time period of simple pendulum. Clear? But we have to find here, given that the length L is about 10 centimeter. Suppose there is a pendulum like this, and this is bob of the pendulum, and this is length, and here mass of the pendulum, and this point is fixed point. And given that length of the pendulum, that is L, equal to is about 10 centimeter, and its length, which is equal to 10 centimeter, but it is known to 1 millimeter accuracy. What is accuracy? It is the error in measuring device, the device which we use, and here the error which is equal to 1 millimeter accuracy. So you can write here error limit means delta L. So delta L equal to 1 millimeter accuracy. But we have to first write here, if here centimeter, then now we have to convert it 0.1 centimeter. This is least count, we can say least count. And this is the least count of meter scale. So the least count is equal to 0.1 centimeter. Clear? Now, the period of oscillation is about 0.5 second. Period of oscillation means this is the mean position of pendulum. Now displace the pendulum or just displace the pendulum towards extreme position. This point is extreme position. Suppose this point is A, and after release the pendulum from extreme point, then it come back to the mean position, and again extreme point. This point is B, and again return back to the original position. Clear? And this is known as one oscillation. To complete, this is one oscillation, and total time taken T, and T is here given, that is 2 pi L by G. Clear? But here given that the period of oscillation is about 0.5 second, means while we release the pendulum from point A, extreme point, then it come back to the point B and again return back to the point A, and it will take 0 point, which is equal to 0.5 second. But again given that here the time of 100 oscillation is measured with a wristwatch, which is equal to 1 second resolution. 1 second resolution means here error. There is a stopwatch which give error limit, that is 1 second resolution. Means we can write here time, the measurement of time, and here the error in measurement of time by wristwatch, that is delta T equal to 1 second. But first we have to find here what is time, total time here, because for one oscillation it will take 0.5 second. For 100 oscillation it will take total time T equal to 0.5 into 100 second. Clear? Or which is equal to 5 by 10 into 100, then this is 50 second. So total time for the calculation of time period of pendulum, that is T equal to 50 second is here. Clear? Okay. But we have to find here what is accuracy in the determination of G. G is here acceleration due to gravity. So how can we find the percentage error in calculation of acceleration due to gravity? Because given that T equal to 2 pi L by G, now squaring both sides, then we will get here, that is T square equal to 4 pi square into L by G. Clear? But here 4 pi square, this is constant quantity and it don't possess any error. Clear? This is constant, 4 constant, and the value of pi is 3.14, which is also constant. So the error consists of L, T, then error we have to calculate in error G. Clear? But we have to find G here. So G equal to, I am writing here G equal to, it is 4 pi square L by T square, and here there is no error in 4 and pi square, and the error which consists, that is L, length of the pendulum, and square of time period. This is another one lesson. Clear? So we have to find percentage error in G. Now how can we find percentage error? First we have to find here delta G by G relative error, which is equal, this is division case, and delta L by L. So you can write here delta L by L plus, and power format, so I am writing here 2 into delta T by T. Clear? What we have to calculate here? Percentage error. Percentage error means we have to multiply on both sides with 100, then your 100 equal to delta L by L into 100 plus 2 into delta T by T into 100. This is now converted into percentage error with G. So here delta L and its value given, the delta L equal to 0.1 divided by L L is here 10 centimeter into 100 plus 2 into delta t. Error is here 1 second. So 1 second divided by t is here 50 second into 100. Now solve this relation. Then we can write here this is 1 by 100 into here 100 plus here 1 second, that is 52, then 2 to 4 is here, then I am writing here 100 cancel, so 1 plus 4 which is equal to 5%. Clear? So calculation of error in oscillation due to gravity of time period of simple pendulum, which is this is the answer, which is equal to 5%. Clear? Now let's start another one question based on time period of pendulum. So the least count of a stopwatch is given, that is 1 by 5 seconds. Least count means this is error limit, so you will given delta L which is equal to 1 by 5 second. This is first error, and we have to find the given that here the time period of 20 oscillation. Time period of 20 oscillation of a pendulum is measured to be, means total time for the oscillation of 20 oscillation, which is equal to that is 25 second. What is the maximum percentage error? So we have to find here what is the maximum percentage error given the delta t. Delta t is here 1 by 5 second and t is here 25 second. We have to find maximum percentage error. So percentage error in calculation of time period of simple pendulum, that is delta t divided by t into 100. This is percentage error in calculation. So delta t is here, given delta t, that is 1 by 5 into 1 by t is here, so 1 by t equal to 1 by 25 into 100. Clear? So here 5 4 is 100, then 4 by 5 which is equal to 0.8%. Clear? This is percentage error in calculation of time period of simple pendulum. Now let's start another one question. And here given that the radius of a sphere, which is r equal to 10 plus minus 0.1 centimeter, that is the true value of radius, that is r equal to 10 centimeter, and error in measurement of radius, that is delta r equal to 0.1 centimeter. Now we have to calculate percentage error in its volume. So the volume of a sphere, that is V equal to 4 by 3 pi r cube, but here we have to calculate percentage error in its volume, and here this is 4 by 3 pi. This is a constant quantity and it has no error, so we can write directly that is V equal to r cube. Means if measurement of radius of a sphere and its consist error, then the final result also consists error. This is constant quantity, so I am writing here V equal to r cube. Means we have to find delta V by V into 100. This is percentage error in volume. Percentage error in volume of sphere, which is equal to delta V by V into 100. And this is power form, so we can write 3 into delta R by R into 100. Clear? Now use value here. So 3 into delta R by R. Delta R is here 0.1 divided by R is 10 into 100. Then 10 times 100, so here this 3 into 0.1 means 1 by 10 into 10 cancel, so 3%. Clear? So the percentage error in calculation of volume of a sphere, if given radius equal to 10 plus minus 0.1, then answer will be 3% error. Clear? So these are all about numericals based on dimensional formula, use of dimension by using the principle of homogeneity and error limit. Clear? Thank you all.